Good morning, everybody. Today I will start the topic firefighting machinery. The firefighting machinery includes like fixed installation, portable installation, different types of machineries are there, different types of chemicals are there, different types of fires are there. Then what are the different types of fires? How to extinguish and what are the machinery or mechanism will be required for handling fire when you are in the ocean, let's say ship or offshore platform, oil platform, or maybe research platform, research vessel, your cargo ships, anywhere fire can occur. So that fire, if not controlled properly, that can be disastrous. Okay, and the content I have taken from basically book from D.A. Taylor, and many topics, figures I have taken from different sources. I have given link also. If you like to study further, you can go through the link and you can study. And if you go to marine engineering book D.A. Taylor chapter 13, you can see the fire safety chapter is there. So fire substance combined chemically with oxygen. So let's say wood or paper, anything you just keep on fire source, it will burn, and when it is burning it will take oxygen. Okay, so air is required, air means oxygen must be there. So typically it gives out light, heat and smoke. Smoke is basically some particles or some chemical agent, and it looks like gray or blackish color. Old English FYR, this term derived to fire. If you see Indian book Rigveda, so there Agni word is used. The first word laid down in the Rigveda, the oldest extent of Sanskrit writing is Rigveda. Okay, and many firefighting websites, they write fire as a find, inform, restrict, extinguish. When you see any fire, so first you have to inform that okay there is fire, or if you know somewhere there is any fire extinguisher or you can handle the fire, then you can go through and go to that place and handle the fire. Okay, and let's say fire is gradually extending, so you have to restrict also within certain limit, and you can handle man or machine accordingly, and finally you can extinguish completely. Okay, so because if you are untrained, then you may not be able to handle completely, so maybe you can find, you can inform, that two things you can do. uh, Here one picture I have given, taming flames, igniting safety. So different companies, they are making the different fire safety system. This is one carbon dioxide based system. So carbon dioxide one funnel sort of thing is there. So for carbon dioxide will be coming out from the cylinder and it will be extinguishing fire. But again, the same carbon dioxide cannot be used for all type of fire. For example, another type will be there, let's say water. Water also can be extinguishing fire, but if there is an electrical short circuit, there you cannot add water. Okay, so you should have different types of fire extinguishing system, so that will be handling fire for different chemical or different conditions. So we'll see one by one what are the different fires and how to extinguish, what are the different mechanism used for that. First we should know what are the disasters happened in the recent past. Deepwater Horizon oil spill, it happened in 2010 April 20. So it was the world's largest disaster, actually oil disaster. Lots of oil went into the sea, and because of this one, lots of sea creatures, animals got died, and lots of environmental loss was there. And this Deepwater Horizon was made by South Korean company. It was Halliburton was doing for cementing job, and British Petroleum got the contract, and they were drilling and trying to get oil and gas from the wellbore. Normally this oil rig will have one blowout preventer. Let's say this is water surface, this is your seabed. Okay, so from what your semi submersible is here, Deepwater Horizon is actually semi submersible. So the semi submersible is here. From here you are drilling well bore. Okay, and when you are drilling, oil and gas will be there, maybe somewhere here. So when oil and gas is there, you are drilling, suddenly this oil and gas, because of high pressure, when you are drilling, actually sometimes you face very much high pressure under the earth surface. So that high pressure will be pushing oil and gas out of the wellbore. So to handle that one, normally they will have one blowout preventer called BOP or blowout preventer. And if there is sudden kick or suddenly oil and gas coming out from the wellbore, so blowout preventer will be stopping, even sometimes it will be cutting the pipe and stopping the flow. Okay, that mechanism is there. But somehow the BOP did not work and oil and gas moved through riser. This is actual riser. Okay, riser means the pipeline inside water carrying oil and gas or drill pipe, anything going to platform or platform to wellbore. So that pipe is called riser. So through riser it went to the platform. So their platform, they had engine, they had safety mechanism, everything, but still somehow it got some spark. Because of the spark, fire started, and fire will be contained, but there was source of oil and gas, continuously oil and gas was coming out from wellbore. So that made everything disastrous. So oil and gas is coming out and fire is there. So fire continued, and finally 11 workers died and many got injured, and finally the whole Deepwater Horizon semi-submersible got sunk in the water. And then when sunk, then oil and gas is coming out from wellbore, you cannot handle, and your man, everything got removed from there. Now you have to control the oil, control the fire. You have to stop oil and gas coming out to the ocean, because the oil will be creating pollution, oil pollution. Gas maybe it will be evaporating, but both, whatever oil and gas you are getting, you have to stop things. So lots of effort was applied, and finally they controlled the production of oil and gas, and later they started producing again, but it was very much disastrous, this event. Okay, so fireboat responses responded, and Deepwater Horizon, Gulf of Mexico, 2010. Okay, now similar event, smaller event happened at Mumbai High North fire. Mumbai High North, the fire happened in 2005. So 100 kilometer off coast the Mumbai. So from Mumbai coast to inside sea, 100 kilometer. So support vessel and production platform collided. Production platform, normally spar platforms are there in Mumbai offshore, and they are producing power from the last about 50 years. And about 22 engineers died and damaged about 370 million USD. So huge amount of losses was there. So main thing happened in the offshore case is, like, one is life will be in danger if you are not handling fire properly. Next thing is that your machine and production and environment and other issues also there. So somehow you have to design things which will be like fireproof, and if there is any fire source, how to handle it, how, like say oil and gas, already it is combustible. If it is mixing with air, that will be combustible mixture. So the oil and gas engineers, they always try to make everything safe, but still things happen. So first you have to know, whenever you are working or designing or working for offshore areas or designing offshore systems, then you have to consider all the aspects. If any combustible fluid is there, let's say cargo will be carrying combustible fluid, let's say coal, Australian coal is coming to India, or Middle East oil or gas or something is coming to India, or India exporting that oil and gas or coal or something to outside country. So combustible mixtures also getting transported. So if there is any small fire source, then everything can be disastrous. So you have to handle it. During design stage, actually you have to consider all the aspect, and accordingly you have to design your shapes or your machinery, whatever you want to design. Now there is one example of fire on ships. Fire on ships, one news item was there. This is Forbes news item. The number of fires large shipping vessel increased actually. In 2022, the highest number of fire incident of ships happened. 200 large ships fired and 43 were cargo container ships. And insurance agency, because when fire will be there, insurance agency will be coming into play. Normally everything will be insured by the companies. So they did all the calculation, because they need to get the information how many fires are there, how much money they are taking, because they want to get profit also. Okay, so huge amount of money will be investing and they should get profit. So they should know the statistics, how many fires are happening and how much money they are paying. So based on that, they will be calculating the EMI. Okay. So insurance firm indicated that cargo ships, they are handling dangerous goods, especially the flammable goods. If they are transporting, the fire probability is higher. Okay, here you can see right side on picture, a cargo ship in North Sea caught fire in 2013. Okay, there will be many such example. For example, 200 ship fire already there in large ships. So if you Google it, you will find lots of such example of fire. So when you are designing ship, you have to consider fire safety aspect, how things will be getting safe. For example, one is life, another is machinery, environment. So actually three things: machinery, environment, and life. Three things you make safe, then you design and you move on. So what about international code? FSS code of the International Maritime Organization, or IMO. FSS code or fire safety systems. Fire safety systems code, international treaties organized by IMO under the International Convention of Safety of Life at Sea, SOLAS. Okay, so they had created FSS code to reduce fire risk and aid in emergency response aboard ships. So code covers international shore connection. So specify how to connect shores and ports to refill and fight fires while docked. Personal protection equipment, PPE, apparel and breathing apparatus. Okay, so here one thing I want to explain you, that I was working for oil industry in the UK. So there in laboratory, if you enter, actually you have to wear personal protective equipment. In India normally we do not follow that much of strict rules, but in UK universities and industries they should follow, because they have HSC, health safety executives. So they will be accessing your industry or university at any time if they want, and they will check whether things are safe. Okay, so whenever you are entering into laboratory, then you have to wear hard hat, goggles, you have to wear high vis dress, you have to wear gloves, you have to wear hard shoes if you are working. But if you are only entering, then at least you should wear a hard hat and hard shoe and your jacket, like high vis jacket, like one strips will be there, so it will be glazy, and in dark also it will be, you can see the color, yellow color strips will be there, you can see from long distance. So that to make everything safe, like say if something goes wrong and some worker is got sick and he cannot move, so at least the color will indicate that okay, that person or something is located in that location, so people can take action. Okay, so there are several other rules also there. Only single person should not work in the laboratory, so that rule also there, and that rule is followed by industry and university both. And fire extinguisher type, in FSS code, fire extinguisher, the specification of portable extinguisher will be there. FSS code, fixed gas, different types of extinguisher there, fixed gas, foam, pressure water, we will discuss later of all this, sprinkler, fire detection. So several types of extinguisher systems are there, and the code specify all these things. Fire detection and alarm system, smoke detection system, low location lighting systems, and how to escape from the system. So normally there will be one assembly point if there is any fire in one building. So how to escape, there will be proper clear escaping way, and there will be one fire door, safety door also everywhere in every building, and people will be moving out of from there, and they will be assembling somewhere some in one place where they can be safe. Okay, and fire machines, fire trucks, they can move directly to the fire place. Okay, so that sort of arrangement should be there. So that is the regulation from the UK higher HSC. In India also there lots of regulations, but many time people violate the rules. So when you are talking about fire, so first you have to talk about fire triangle. What is fire triangle? Fire triangle, actually it will have three sides. You can see right side picture: oxygen, fuel and heat. So three side, it presents one oxygen, one heat, one fuel. Okay, so if you break any one of the side, for example, if you have heat and fuel, there is no oxygen, so there will not be any combustion, no fire will be there. Or if you have oxygen and fuel, heat is not there, again no okay, if you have oxygen and fuel and if you don't have heat, then fire may not be there. So what happens, let's say you have certain amount of wood. Okay, let's say this cloth is there. Okay, cloth is there, it is fuel, and oxygen also interacting with this one. although oxygen is interacting, uh, okay, but there is no fire source, so it will not be burning. But in other way, if you see, uh, if you have heat source and oxygen, there is no fuel, so there is no meaning of fire. Okay, so all three must be there, then fire will be there. Okay, now fire triangle, if you read this one, fire triangle or combustion triangle is three component, is having three component actually: heat, fuel and oxygen. Fire tetrahedron. So some other theory says there must be fire tetrahedron. Tetrahedron means like one will be heat, another is oxygen, another is fuel, and another is chemical chain reaction must be there. So if chain reaction, what is reaction? Reaction means like it is exothermic reaction. Okay, when you are getting fire, actually it's exothermic reaction. Okay, so let's say wood is burning with oxygen, it will create carbon dioxide and other products, and carbon dioxide, water and other products. Now let's say you started burning, but there is no chain reaction, exothermic reaction not happening because you cool down, because you added water. Okay, so heat is there somewhere, but it's not connected, and chain reaction not happening, so fire will not be occurring, actually it will be stopping fire. So to get a continuous fire, you should get all the four: heat, oxygen, chemical chain reaction also. So you see, ABS guideline note, they have written like this: the tetrahedron illustrates how flaming combustion is supported and sustained through the chain reaction of the oxidation process. In a sense, the chain reaction phase keeps the other three phases from falling apart. Okay, they will be connecting all other three phases like heat, oxygen, fuel. This is an important point because the extinguishing agent used in many modern portable fire extinguisher, automatic extinguishing system and explosion suppression system directly attack and break the chain reaction sequence in order to extinguish a fire. Okay, so fire tetrahedron, actually picture will be like this. Okay, it will be like this. Okay, so you got four phases. So one phase is oxygen, another phase is heat, and back side of oxygen, this is front side, back side of oxygen is fuel, and let's say bottom side you can make chemical chain reaction. Okay, so four sides we should have four component like heat, oxygen, chemical reaction, fuel, then a continuous fire will be there. So next, when you're talking about fire, so fire, every time you see yellowish color one flame. A flame or flamma in Latin word is a fire's visible gaseous part. It is exothermic chemical reaction. Okay, I already told. So ionized gases will be created. Let's say you see this candle, one candle is burning right side. Okay, solid wax is here, and it will be melted because of temperature will be coming, heat is coming from here. So because of that, top portion will be melted. When melted, after melting, some portion will be getting evaporated. Okay, when it is getting evaporated, or it is getting heat, so combustion will be occurring. So at the central core, oxygen deficiency will be there, so lots of fuel particle will be there, but oxygen deficiency will be there, but outside oxygen will be huge amount. Okay, so outside oxygen will be entering the center core and reaction will be proper and it will be moving up. Now if oxygen amount is lower, so in that case fuel will not be burning completely, so in that case black smoke can come. So if you see your gas cylinder at your gas oven at your home, so there you do not see black flame because the combustion is complete. Okay, when combustion is complete, you get carbon dioxide. Okay, complete combustion, you get CO2. Okay, CO2 actually colorless. Okay, so if it is oxidizing flame, it will be like yellowish bluish color, some flame will be there, but no black smoke will be coming. But if oxygen supply is lower, so in that case CO2 will not be formed, rather oxygen deficiency, because of oxygen deficiency, CO will be formed, CO, carbon monoxide, and some carbon particle will be unburnt also. Okay, so unburnt carbon particle at high temperature nearby flame middle, so it will be yellowish color. At high temperature the carbon will be becoming yellowish color, and when it is going out of the flame, so temperature being it will be going down. So when temperature is down, the carbon particle will be forming black smoke, very small tiny particle, it will create black smoke. So if you have pot and cooking, and if you have lots of black smoke, so all around the pot you will say black some black color thick material will be deposited, that is actually carbon particle, unburnt carbon particle, and lots of carbon monoxide also will be created, so that will be harmful. Okay, so you should have sufficient amount of oxygen to burn fuel. So now smoke, I said like carbon particle will be there, but some more particle also will be there. So what is smoke? A mixture of airborne solid and liquid particulates, gases emitted from a combustion or pyrolysis. Pyro means fire, so using fire some analysis. Okay, so from burning something coming out together with the quantity of air entrained or otherwise mixed into the mass, typically visible as cloud or haze, varying in color from white to grey to black. Okay, so different color may be possible because different concentration will be there, depending on the nature of the particle and amount of the incomplete combustion. It contains chemical including CO2, okay, CO or carbon monoxide, water particle, water vapor also be there. For example, if you burn any organic compound, say wood or paper, anything, so some water vapor also will be produced. Water will be produced, that will be formed at high temperature, will be vapor form. So particulate matter will be there, other volatile component, organic component may be there, because based on your whatever you are burning. So if that combustion is happening because of this simple methane gas, then lots of component may not be there, only carbon dioxide and water will be there. But if you have wood, wood will have lots of components, so you will have carbon dioxide, water, and many other component. Okay, so based on your fuel, what fuel you are burning, you will get that constituent in your flame, yes, in your smoke. So I told you that there are different types of fires. So let's see what are the different types of fires. So solid combustion, like say you have wood, you have paper, you have chair, table, wood and made, so you can burn. So this is called class A fire as per Indian standard. So same symbol is not used for different countries. In, let's say first consider India one. Okay, so as per Indian standard, class A fire means solid combustible material, wood, paper, all these things. Flammable liquid, some liquid you are burning, so class B fire. Flammable gas under pressure, let's say your Indian cooker is having fire, that is class C fire. Combustible metal, some metal, magnesium and other can burn also, they can create class D fire. Cooking media, kitchen fire, let's say oil frying pot is there and some combustion happened, so in that case it is a class F fire. Electrical circuitry, short circuit happening because of the fire, so in as per Indian standard there is no class defined. Okay, but if you see US, class A same, US, India, class B also same, class C you can see changed. Okay, UK, Europe and India, the classes are same, but US is having some difference. So whenever you are reading this classes of fire, so you should see. Okay, so for our exam purpose we will follow the Indian classes. Okay, combustible material D same, cooking media, kitchen also again differing. Okay, Australia also having some difference. For example, electrical fire, Australia is having class E. Okay, for India case there is no class for electrical fire. Other classes are almost same for Australia and India. So carbon dioxide, it should not be used for kitchen fires, because carbon dioxide will be creating further problem, because whole kitchen will be oxygen shortage, so any person, anything is there. So especially living spaces, carbon dioxide should not be used, because carbon dioxide shortage will be there, oxygen shortage will be there, because it will be replacing oxygen, so that will be disastrous. So no for materials like paper. So carbon dioxide you can't use for material like paper, wood or textile. Good for electrical and class B fire. Okay, class B flammable liquid and electrical means like short circuit, anything is there, you can use carbon dioxide. Powder, powder will be created on blanket. Say one fire is happening, and if you apply some chemical powder is there. So powder if you apply, so it will be covering and it will be cut the oxygen supply, and it will be reducing some temperature also, or like flammable temperature. So that will be, it will be extinguishing fire. But powder will not be used for involving cooking purpose. So CO and CO2, carbon dioxide, and powder should not be used for kitchen. Now see different types of fire and how to extinguish it. Okay. So water you can use for paper, wood, coal, cardboard, other solid fuel. Okay. So it will be creating on blanket. Some fire is there. If you are applying water, means it will be cutting oxygen supply, because it will be creating water layer, and it will be reducing temperature also. So flammable temperature will be going down, and it will cut water oxygen supply. So that way fire will be extinguished. Okay, and fire extinguisher color will be red, solid red color. Okay, this is class A fire. And foam. So foam can be used for class B and A type fires. Okay, so foam like dry chemical powder DCP, the large portion of monoammonium phosphate, the powder coats the fuel and cuts oxygen supply. Okay, and if you see, okay, this is powder, and powder can be used for almost all type of fire. Okay, dry powder can be used for almost all type of fire, A, B, C, D, electrical, all type of fire. Okay, this is more common, but normally it will not be kept everywhere, because so based on the fire classes people will be using because of cheaper and other conditions. Carbon dioxide fire. So carbon dioxide takes away oxygen, it will be replacing oxygen, it will be covering that area. No harmful residue will be there, so it may not displace oxygen, may be ineffective for class A fire. Okay, for class A fire it will be ineffective. Okay, and color will be black color and can be used on that cylinder color actually. Wet chemical used for on cooking oil fire as well as combustion fire, solid material, yellow color can be used for A and F. Okay, and if you see this one, wet chemical, a solution of potassium, after reaction with the cooking medium, a thick soap like substance will be formed and will be sealing the surface. Okay, so another type of fire extinguishing system used for kitchen, especially when I was in UK, I was cooking in the kitchen. They will have one blanket, like silk type one blanket will be there. So if there is any fire, immediately cover the fire, and it will be cut the supply of oxygen, and it will be, everything will be safe. So material should not be combustible material, blanket material. Standards on fire extinguisher. So fire extinguisher, the first line of defense in small fires, they are called fast aid fire extinguisher, and different standards are there. BIS standard, for example 15683 2018, portable fire extinguisher. Then wheeled fire extinguisher. Portable fire extinguisher actually very small fire extinguisher, less than 17 kg weight will be there, so you can carry, actually you can lift it and you can go to fire, and you can push oxygen or whatever you have in the cylinder, you can put there. But if you have a larger fire and you want to carry it, so one person cannot carry it, in that case wheeled fire extinguisher will be there. So portable wheeled, some small cart will be there, so you just carry it and you can apply your fire extinguisher to the fire. And wheel 17 kg limit is there if it is portable type, like it portable type will be there in your office buildings, in your every places this fire extinguisher will be there. But for your larger systems 17 to 450 kg, so you need a wheeled system. Okay, now you got fire, different types of fire, you know, you knew this kitchen fire and gas fire. So how to handle it? So to handle, first you have to identify if the fire is there or not. Okay, let's say if visually you can see some fire is there, then okay, you can take action. But in many cases you may not see visually, but temperature is going up maybe, or somewhere fire is there but it is out of your range of your eyes. So in that case you have to handle. So you have certain sensors, so sensors will detect and it will be sending alarm signal to the people. Okay, so there will be three type of sensors. One will be smoke sensor, flame sensor, heat sensor. Okay, smoke sensor, lots of smoke coming, so sensor will be sensing, okay, smoke is coming. So in that case what will happen, it will send signal to the alarm noise, bell or some other signal. So, that way other people will be taking action. Okay. In some cases, and smoke is coming from flame normally, and flame sensor, infrared sensors will be there. So, if there is any flame, it will be sensed. Heat sensor, if temperature is increasing of the room, for example. So, heat sensor will be sensing, it will be sending message or it will be giving alarm signal. So, flame detectors are rarely used on boats these days. Okay. So, flame detectors are almost not used. Heat detectors used at gallery and laundry places. Smoke detectors used in machinery and accommodation areas for ships. Okay. And smoke, let's say start with smoke detector, because three types of detectors we have: smoke, flame and heat. So, first smoke detector, it will have two ionized chamber open to atmosphere. So, ionized chamber will have MSCM 241 or AM 241 material, radioactive material, and it will be ionizing gas. Okay. And continuously electrons will be flowing. Now, if there is no resistance, then electron will be flowing continuously. Now, if you have lots of smoke, smoke will have lots of particle, non-ionic particles. So, that will be interfering this ion motion. When ion motion is interfered, so this amount of ion reaching to other electrode will be lesser. So, it will be sensing that, and after sensing, it will be sending signal, okay, or it will be creating alarm. Smoke particles change the balance of current inside the chamber, because the number of smoke particle is larger than the ionized air particle or ionized air molecules. So, because of that, this balance will be disturbance and immediately alarm signal will be sent. Flame detectors. So, flame actually it will be releasing ultraviolet ray, infrared red ray and visible light also. Okay. So, you can see the right side picture. This is UVC ultraviolet, this is ultraviolet zone, UV zone. So, ultraviolet rays will have like UVC-A, UVC-B, UVC-C, three types of ultraviolet rays, okay, based on frequency. And this is your visible range, and this is infrared range. Okay. So, the scientists they develop the sensor using UVC sensor and infrared sensor. So, light is giving UVC as well as UV as well as IR. So, it's one sensor can have only UV detector or IR detector or both. Okay. Ultraviolet flame detector detects UV radiation emitted by fire, suitable for especially hazards like hydrocarbon, halogen and metal fire. Infrared sensor, it will be observing IR radiation emitted by flame prone to false alarm triggered by non-fire sources. Okay. UV IR, so it will be sensing both. So, it will be more complex and it will be sensing both. Multi-spectrum infrared flame detector, multiple IR wavelength are used to distinguish flame produced by producing radiation and other sources, and they can detect fire up to 200 feet away. So, if it is away from the system, still it can detect. Visual flame imaging system also possible, and these days AI and other machine learning algorithm also being used to develop newer type of technologies. Heat detector. So, we have seen flame detector, smoke detector. Now, we see heat detector. Heat detector is very simple. If you have metallic strip, so you can detect actually. So, it is designed to detect temperature change. Okay. There are two main types of detector. One will be rate of rise of temperature and fixed temperature. Okay. So, it will be detecting a rate of temperature rises and fixed temperature. Okay, it will have fixed set of temperature. If temperature crossing, your room temperature is crossing that set temperature, then it will be sending alarm. For example, a fixed temperature heat detector might have might set to trigger an alarm when temperature in the room crosses 50 degree. So, 50 degree is my set temperature. Ships rate of rise detectors are used in the gallery, smoke room and laundry room, because smoke is present in these areas and smoke ship rate of rise detector is in the gallery, smoke room, laundry room, because smoke is present. If somewhere smoke is already there, so and you are fixing smoke detector, so it will not work, because already this smoke will be interfering ionization and it will not detect, or it will be giving false alarm. So, in that case you can use rate of rise heat detector. Okay. Heat detector's principle operation, liquid expansion. So, liquid expansion also possible, low melting point material, bimetallic strip. Bimetallic strip, you can remember, two metals will be there, okay, and with different thermal expansion coefficient. So, if you increase temperature of these two, because of this different thermal expansion, this bimetallic strip will be making more curve or more flatter, okay, and because of that you will have some connected electronic sensor. So, that will be saying that okay, temperature increase, because of that bimetallic strips change its radius of curvature, and when it is change radius curvature, your sensor will say okay, temperature increase, send alarm signal to the people. Now, is detecting element of the heat detector is the relative movement of two coiled bimetallic thermostat, one exposed, another shield, okay. It will be protecting property based on temperature. Smoke detectors protect property and people and property, okay. So, heat detector may not be used for your room and other applications, so but it will be used for where cargo ships and other things are available, and maybe many human being and things are not there, only machines are there. So, heat detector may be helping, but for room and other applications you should use smoke detector instead of heat detector. And heat detector, it is based on temperature, so it will not respond if it is there is any smoke or air. So, now fire main system. So, one portable system will be there, another fixed system will be there. A crucial component of a vessel's firefighting capabilities comprising sea inlet, suction pipe, fire pump. So, pumps will be there actually, okay. So, it will be high pressure pump and distributed piping system, fire hydrant will be there, hose will be there, nozzle, okay. So, purpose provide source to combat fire. So, these are fixed type fire installations, and for larger fire handling, for smaller fire handling, so you have portable system. For large amount of fire, so big systems, big rooms, so in that case big buildings, in that case you should have fixed fire handling system, okay. So, water distributed by hose lines, straight stream formed by nozzles. However, only small portion of the water surface contact with the fire, limiting its efficiency, okay. So, whenever any fire is there on board, so you have to control the fire also, okay. So, small portable device will be there, and large main fire systems will be there. So, small portion it will be in corridor, it will be in staircase, it will be kitchen, everywhere, but large systems will have whole building or whole ship, there will be piping systems and it will be controlling. So, portable extinguishing system, usually 4 portable systems are there. Soda acid extinguishing system, foam, dry powder, carbon dioxide, basically 4, there may be many others also, and newer research also going on. So, new technology also be coming up. So, soda acid system, it will be having sodium bicarbonate and sulfuric acid in separate container. Now, when there is any fire, just break the container in between wall and allow them to mix up. When they are mixing up, it will create sodium sulfate, water and carbon dioxide. So, lots of carbon dioxide will be produced. So, in lots of carbon dioxide will be produced and is target the nozzle towards the flame. So, it will be fire will be extinguished, and normally it will be used for class A fire. And foam extinguisher. So, foam extinguisher, again it will be having aluminum sulfate and sodium bicarbonate. So, together after reaction it will be creating lots of carbon dioxide, aluminum hydroxide, sodium sulfate. So, this will create lots of foam, carbon dioxide will create lots of foam, and it will be covering the flame area or combustible material area, and it will be cutting the oxygen supply. Carbon dioxide exchange, liquid carbon dioxide at high pressure, it will be kept inside cylinder, and when you purge or you create a small leak, so liquid carbon dioxide will be coming out, and because of low pressure it will be expanding, okay. When it is expanding, it will be covering the whole fire area and it will be cut oxygen supply. And again liquid carbon dioxide, when it is evaporating, it will be creating cold air, cold carbon dioxide actually, cold gas of carbon dioxide. So, it will take lots of heat also. Dry powder extinguisher, so it will be like general purpose extinguishing system, sodium bicarbonate, again at high temperature leaving carbon dioxide. So, that will be used for your extinguishing fires. So, fixed installation, fixed firefighting installation are designed for there are different types of fixed firefighting installations and designed for different types of ships. Okay. Every ship has seawater supply system connected to fire hydrant. Multiple pumps in the engine room will be supplying water to the system, and the number and capacity are regulated by maritime legislation. Any emergency fire pump will be there. Okay. So, using this one you are controlling your fire on board. So, thank you very much for today's lecture. Next day we will come with new topic. Thank you very much.